Alright, hey guys, my name is Matt and I am an MCAT tutor, and today we're going to go through a practice MCAT passage, and this passage is going to deal with acid-base chemistry. Acid-base chemistry is a pretty high yield topic on the MCAT, so this is definitely something you're going to want to have down for test day. And the way we're going to do this is I'm going to let you pause the video, read the passage, and then we'll go through it together. And then after that, we'll do a question based on the passage. So go ahead and pause the video right now, read the passage. Alright, so hopefully you guys have had time to read that passage. So as far as Chem Phys passages go on the MCAT, this one's not too long, which is nice. And basically they're just introducing to us this concept of hydrolysis. The fact that when you have these metal cations in solution, they form these little water cages as they show in reaction 1. And that basically lets them work as an acid, even though they don't actually have protons to donate, which is kind of cool. And the detail of kind of how this works is explained in paragraph 2, and they actually show us a nice little picture, and basically the delocalized electron cloud around that center atom allows one of these water molecules to ditch a proton and basically act as an acid, and then whatever water is not surrounding that, it's going to pick that up and become a hydronium ion. Now the one other thing I want to point out from this is that this normally happens with highly charged metal ions where that N plus is greater than 2. So you're not really going to see this with something like sodium. That's not highly charged enough to have this effect. And the other thing that I really want to focus on is the fact that that's weakly acidic. So just want to draw attention to this. And so basically that means, you know, we have our strong acids like HCl and stuff which dissociate completely, really low pKa values. If you put that in solution, the pH is going to drop considerably. These ones are weak acids, so yes, it acts as an acid, but not nearly to that extent. And really, guys, there's not much more we need from the passage, especially for this question. And luckily, as far as MCAT passages go, this one is not too intensive. But let's take a look at the question. So I'm going to take us down here. And I am going to do the same exact thing that we just did, which is I'm going to let you pause the video, read the question, try to work it out on your own to see if you can do it, but we'll go through it together. So go ahead and pause the video right now and see if you can work through this question. Alright guys, so hopefully you all had a chance to kind of go through that question. So let's go through it together. So on the MCAT, they can throw lots of stuff at you. It can be very confusing. And so the first thing that I like to do in terms of problem solving strategy is let's just take stock of what we even have. So one of the values they give us is this 0.1 molar aluminum aqueous solution. And another thing they give us is this pH value. They give us a value of 3. Aside from that, they just say that the solution was observed to turn the blue litmus paper red. That's really just to indicate that it is actually, you know, working as an acid. There's some acidic activity present. And then the last thing they say is we don't know the pKa because we can't find it in the literature. And what I like to do on the MCAT is, because a lot of this work can get messy, or again, all the variables can get confusing, is I always like to write down, what am I looking for? That way, as I'm working through the problem, if I ever get kind of lost in the math or lost in the variables, I can always go back and be like, okay, wait, what am I trying to find? And for this one, it's the pKa. So for this one, we're going to write pKa equals question mark. And to solve this equation, we're going to use our Henderson-Hasselbalch equation. Now, if you know this equation, awesome. And I'm going to make that a capital H just to be correct. And if you don't know this equation, no worries, but this is something you're going to want to know by test day. As you probably know, for the MCAT, they do not give you an equation sheet, so any equations that you use, you will have to know. And this is one of those equations that they absolutely love to use. I mean, yeah, this is like one of the main ones to know. So this is worth memorizing and doing practice problems to get comfortable with it. So here we have our Henderson-Hasselbalch equation. I know that this probably looks a little intimidating if you're not familiar with this equation, but basically what it's saying is that the pH is equal to the pKa plus the log of the conjugate base, which is that A minus, over the acid, which is HA. So there's a lot of different variables here, but let's just break it down into smaller chunks and kind of fill in what we got. So we have the pH, they gave that to us, that's awesome. So we have 3 equals pKa plus log And then what are we going to do about this A minus over HA here? So this one now we got to be a little careful on this one because it's going to get a little confusing. So in this problem, they tell us that we have this 0.1 molar aluminum aqueous solution. Now, if you remember from the passage, these aqueous metal solutions can act as acids, right, when they do that little water cage. And so that is actually going to be the concentration of our acid. And just for anyone who's not familiar with this equation, the little brackets indicate the concentration. So for this HA value right here, our concentration is 0.1 molar. Now personally, and I'm probably going to get a lot of pushback on this, but I like doing scientific notation when it comes to math on the MCAT because it makes the math so much easier once you get comfortable with it. We can do another lesson on that, practicing MCAT math since you don't get a calculator. But you can either write 0.1 or I'm going to write 10 to the negative 1. And that's our concentration for HA. Now, we got HA pretty easily, but how do we get that A minus? We didn't get a concentration for amount of conjugate base, but what we do have is the pH, and that's going to help us out. So I'm going to actually just move this over to the side for a second since we're just kind of solving this in smaller chunks. And one really useful thing to know for the MCAT is that concentration of protons is equal to 10 to the negative pH. That's going to be something you're probably going to use a lot. So what that basically means is that our concentration of protons in this solution is 10 to the negative 3 because our pH was 3. Now, you might be going, okay, Matt, that's cool. That's our concentration of protons, but what we need is concentration of conjugate base. Well, we saw from the passage that these weak acids are able to donate 1 proton, right? So if we have 10 to the negative 3 protons, that means our amount of our concentration of conjugate base is also going to be 10 to the negative 3, since these acids work in a 1-to-1 ratio, right? For every acid, it breaks into 1 proton and 1 molecule of conjugate base. So what we're able to do here, oops, let me redo that, is we can say that the concentration of H plus is equal to the concentration of A minus. Oh, sweet. Then we know that the concentration of A minus is going to be equal to 10 to the negative 3. Boom. All right, so then let's plug that one in there. So going back to our green equation, that's where we're filling everything in as we go. It's our main equation. We have 3 equals pKa plus the log of 10 to the negative 3 over 10 to the negative 1. Now, if we use our rules about exponents on fractions, which again, we can do another lesson on that, but that comes out to pKa is log, we're going to do negative 3 minus negative 1, so plus 1, log 10 to the negative 2. Oops. Forgot my log there, and that's actually going to be very important. Cool. So now you might be thinking though, Matt, that's cool, but again, no calculator, and you want me to do log of 10 to the negative 2? Whenever you have a log, let's see, what color are we going to go with here? Let's go gold. So whenever you have a log base 10 of anything, the log and the base 10 will cancel out. So if I have log base 10 to the negative 2, again, the log and the base 10 will cancel out, and you bring that exponent down. So what this actually turns into is just 3 equals pKa. Now, I'm going to switch this to minus 2 because I don't like saying plus negative 2. That's just going to get confusing. But pKa minus 2. Cool. And then now from here, we're just going to do some super simple algebra. Going to add 2 to both sides because, again, we're solving for pKa, so we want to get that on its own. Going to add 2 to that side. And 5 is our pKa. I'll go ahead and circle this in red. And if we go back up to our answer choices, we see that that is choice B, and lo and behold, that is the correct answer. So just to review, guys, when you're going through questions like this, it's really helpful to, at least in my opinion, to break it up into smaller chunks. So we said, okay, first we got pH, check. Then let's get concentration of A minus. We had to do a little bit of a workaround for that, but again, as long as we knew that principle, we're able to get it. Then concentration of HA. Okay, cool, that was given. And then we just start filling it in. Now again, if you're not comfortable with this, exponent math and the kind of mental math stuff, totally fine. There are some definitely pretty nice ways to be able to get comfortable with it very quickly, so we can work on that in a little bit. Yeah, and then after that, like I said, if you know your logs, that cancels out, and then this last part was just some very simple algebra. Now, if you're taking the MCAT, time is a major factor, right? And on test day, you might not be able to take this kind of time with every single question. You might get bogged down on one question, and that's okay. So one really big aspect to the MCAT too is just test taking strategies in general. So that way that we just went through was the quote unquote long way to do it, but the thorough way. Here's another way to get to that answer if you're on a time crunch, or maybe if you don't know your Henderson-Hasselbalch equation and you won't be able to go through and do all the math. So we know that pKa is essentially the pH at which that acid is 50-50 protonated, non-protonated form. So, yeah, and the other thing too is the pKa values indicate the strength of an acid, right? So pKa of, either 0 point something or in the negatives, that's a super strong acid. That means basically that no matter what solution you put that acid in, that's dissociating. If you have a pKa of obviously 7, that indicates something that's neutral, and really anything a pKa above 7 means that it's more of a basic agent. It's more of a base. And so with a weak acid, again, pKa is that pH level where it's 50-50 acid state, non-acid state. So with a weak acid, you're gonna have a pKa that's kind of closer to, again, closer to 7 since pH of 7 is neutral. So it's said right here, and we highlighted it too, that these solutions are weakly acidic. Now again, knowing what you know about pKa, you know that, again, pKa of 7 would mean that this is essentially a neutral compound, so we can cross out C. pKa of 8 would mean that it's a base, so let's cross out D. So now we're left to A and B, and from here you can either do a 50-50 guess, if you're not sure, or if, again, if we pause and kind of think about it for a second, if we have an acid with a pKa of 3 and an acid with a pKa of 5, the one with 5 is going to be a lot weaker of an acid, right? So, and the pH scale is on a 1 to 14 scale roughly, so anything in that 1, 2, even 3 range is pretty strong, right? That's a pretty low pH. So just going off of what again, conceptually, what you know about chemistry, you can kind of make a guess that a pKa value of 3 would be closer to a strong acid than it would be a weak acid. And so you can cross out A, and sure enough, you're left with B just by process of elimination. And that is the right answer. So again, obviously, if you have the time on test day, I highly recommend doing the full version of it. However, if you are on a time crunch, little things like this, or if you're on a time crunch, or if you just don't know the equation, because it's very hard to know all the content for the MCAT, try to see if you can kind of logic or reason your way through it, because a lot of times in the MCAT, you will be able to do that if you don't actually know the specific equation. So anyway, guys, those are 2 ways to solve that question. Hope all that made sense. Definitely feel free to go back, rewatch, pause the video, and let me know if you have any questions. But thank you.